Hello everyone and welcome. We're back here in the Unity Hub because we're ready to start working on our real-time strategy game. This lecture is going to be very similar to the lecture in section 1 where we set up our project, except this time we can cut some corners and do things a whole lot faster. I think it's safe to assume that you have 2020.1 installed if you follow the first section, so we can now go to New, and it's on 2020.1. We can make a universal render pipeline template again, and we can call this real-time strategy, like so, and create the project. Now that the project is open, I don't want the animator, so I'm going to right click close that. If yours is open, we don't really need it. And I'm going to resize these windows a little bit. I just don't like the way it's opened up. And I've decided to actually go ahead and create a new project here rather than duplicating the one we already had. We could definitely have duplicated that and made it work by just removing some of the stuff we've added, but I feel like it's best to make it from scratch here, though we can salvage a few of the things. If we were to head up to the window right now and go to the package manager, obviously we're back to having all our packages wrong, and I don't want to make another lecture here where I just go through adding and removing packages. And because we want the exact same packages that we installed in the previous section, what we can actually do is we can right click in our project and show in Explorer. And if we go ahead to the packages, we actually just have this manifest.json. So if we were to right click on that and open that in something like Notepad, just any text editor, you see this is actually, this is all our packages. Now, what we want to do is we want to go across to our other project where we had all our dependencies, and we can actually just copy the text from there, paste it into here, and Unity will do everything for us. So if you open up your other project directory, you'll have your files something like this. And if we go to the packages folder again and the manifest.json, right click, open that in some text editor, what you can do is do Control A, Control C. So now I've got this all copy pasted. I can close it, close this. And then if I go back here, I can Control A, Control V to paste, and then Control S to save. So I've just simply copy pasted all the stuff into here. Now if I close this and go back into Unity, notice how it's saying resolving packages. So we'll have to give it a second. So I'll be back when it's done. When it gets to the part about the input system, it'll ask you if you want to restart. We'll say yes, so we can use the new input system. And now that Unity is finished, I can go to Window, Package Manager, and you'll see when it loads in a second that all our packages should be correct, like this. However, as of making this video, there appears to be an update to Cinemachine 2.6.1, so I'm going to go ahead and do that while we're here. Great, now that the packages are done, we can go to My Assets, and remember last time, Mirror may or may not have been here for you, but because you've all definitely got Mirror now after following section 1, Mirror will show up here, in which case you can just hit Import, give it a second, and it'll ask you where in your project you want to import it. And we also, as I said last time, don't want these extra two that come with it, we just want the Mirror folder, and I'm just going to import it like so. Now that Mirror has imported, we can get rid of the things that we don't need in the scene. So we can get rid of the example assets, we don't need any of that. We want to keep the materials, keep Mirror, we can leave the presets, the scene's fine. We don't want the camera controller script that it gives us, so let's click and delete that. And then once that's deleted, we can go to our camera and see the script is now missing, so we can click and remove component. Settings are fine, tutorial info we can get rid of, and the readme we can get rid of too. We don't need that from the template, so delete, delete. We don't need the assets game object in the scene, delete. And we're left with camera, light, and post-processing volume. We're all good to go. And for those of you wondering with the packages, we have this little bit of UI here for ProGrids. This is ProGrids, one of the packages we installed. And if we go to Tools, Pro Builder window, we can then click get this window and dock it over here by dragging the name. And we can resize this. And these are both going to be used in conjunction with each other to help us build our level. They're really useful. You can do stuff such as make a new shape, and there's also options for different shapes to make. And then you can, just like as if you were in a modeling software, you can click vertice mode, click on a vertice, and you can move that. So it's really useful. This isn't a lecture teaching you how to use this. I just wanted to show roughly what it does. So you can move your object, click on an edge and move the edge instead. So we'll be using that to help build our level. But for now, we'll just delete the cube. And I'm going to put this right click into icon mode. I prefer icons, so you can make this smaller as well. And you can mouse over things to see what they do. So new shape and UV editor and so on. We won't be using most of these tools, but a few of them are useful for blocking out our level and adding a bit of terrain to it, like a few obstacles and stuff. So yeah, that's it for this lecture. We have a new project set up. We've got our folders all correct. We've imported all the packages we need, imported mirror. We could, make an empty game object with a network, everything's in here, you see here. So we're ready to go and start building the RTS now. Hello everyone and welcome. In this lecture, we'll be doing the final part of the setup because we'll be setting up our network manager and our custom player and then importing some assets so that we have these vehicles to work with. We can use some tanks and some cars so that we can, by the end of this lecture, hit host, hit client, and have these two players spawn in as tanks in the scene. It's nothing special that we haven't already done. It should be pretty easy to follow. Just the importing might be new to some of you, but the rest of it we did in section 1 with the setting up of the network manager and the player objects. And the reason we're doing this is so that we have it all ready. We have the foundation there so that over the coming lectures we can start building some interesting systems like the spawning in of units and buildings, adding money for the player and adding health and attacking and all the fun stuff in an RTS. We need to get this done first. Let's get started. So if you look in the resources of this lecture, you'll notice a tank asset zip. And if you download that and we import it into our project, you see I have it here. It's just a zip file. I'm going to right click, show in Explorer, and then go to this assets, and it's tank assets, so down here, it's a zip. So I'm gonna double click on it, and it'll ask me here to extract all. So if I hit extract all, it'll then extract it into my tank assets, yes. And then I can close these windows, and you'll notice now in Unity we have an actual normal folder, so let's delete the zip. And what we have in here, if we look in here, we have tank exports, and then we have big tank, classic car, tank with laser cannon, and triple gun car. And these are all models made by Grant Abbott, who works with GameDevTV as well. He has a YouTube channel too. You can find his Blender tutorials on YouTube and course on GameDevTV. And he helped by making these assets. So if I was to drag in this big tank and go to the scene view, double click on the big tank, we see over here we have this tank. So we want to do a little setup with the assets, and then we can move on to make our player object. And for now, we'll make the player object an actual tank. Then we'll move on to changing that when we have units spawning, because right now we don't want a single unit tied to the player. We want no units tied to the player, and then the player can spawn in units and, multi-select them, tell, this bunch to go here and this bunch to attack there, and so on and so forth. So let's do that little bit of sorting out I mentioned. You'll notice how we have two materials, the color grid and the emission. The color grid is for the entire tank apart from these lamps, the little lights on the back. And the emission material, we can add glow and do some post-processing later, but that's just for visual stuff we don't really care too much about. But let's actually fix the material here. So this color grid, if we click on it, it takes us over here to say this asset we've imported has some extra assets with it. So it has the mesh data for the tank as well as these two materials. And you'll notice Unity has got it all a little bit messed up. Like this is kind of some bluey gray color. We want this just to be white. So we can't change it in here. It's actually linked to the asset we've imported. So what we can do is we can click extract materials and then just press select folder. It'll do it in this folder. And now these materials are separated here. And what we can do is we can now tweak them. So you can say here, let's just change this to be white. And now it has the actual color that it's meant to be. It's got the green here, the darker green on the top, and you can see all the colors a whole lot better. And we kind of want to do that to all of them. So what we can do is we can go to the car basic like this, and we can drag in our color grid and our emission and hit apply. And now if we drag in the car basic, this isn't as green anyway, but it still gives it slightly different color than what it was like if we didn't add the new materials, because the ones they all come with are slightly tinted to like this bluey gray, as I said. We want it just to be all the same. So if I was to drag in this here, on the tank with laser cannon, drag in the emission here and hit apply. We can now drag in this vehicle. And we see this is all working now. And then the triple gun car, like this. Let's just put it with the rest. And then we can drag in to here, the color grid and the emission and hit apply. And now everything all looks correct. Also, none of these assets actually have any animation or rigging, so I can control click and select the 4 of the assets, and on rig I can select none and apply, and on animation I can turn off import animation and apply. And I just want to make sure, has that done it to all of them? It has done it to all of them, good. So you'll see here, I just laid out the tanks in a line so it's easier to see them all. We've got all the vehicles, and I'm going to pick, for us to use right now, this tank here. This is the course thumbnail. You can pick whichever you like as your kind of first unit. We'll be doing a bit more work with them all later. It doesn't matter which you pick, it's just kind of a placeholder. So I'm going to delete the big tank, the basic car, and the triple gun car. So we're left with this laser cannon tank. Let's make an empty game object called player, and then put the tank model as a child of that so we can separate the player logic from the player model. So that's pretty good for now. Let's make a prefab out of our player so we can spawn it in. So we'll go back to assets, and we can go to, let's make a prefabs folder. We don't currently have one. Prefabs. Oh, it didn't like that. Okay, create folder prefabs. Open it up and drop in our player. And we can get rid of it from the scene. But actually, no, let's leave it in the scene for now. Let's reposition the camera so we can see a bit better. Because if our tank is currently in, the origin of the world right here, our camera can't really see it very well. So let's reset, let's click on the camera, then reset the rotation. And if we go to the scene view, you'll notice it's facing in the wrong direction. So let's put the Y as 180 so it's flipped to the other direction. And we can use these gizmos or drag the XYZ to kind of position it a bit better. Drag it back, drag it up, and tilt it down a bit so we can see the tank a bit better. It's up to you, just get it so it looks pretty good. And then over here, as for the X, I'll set that to 0, and yeah, you can pick some nice values here, like 4, and 8, and 20, and I'm happy with this. So there's one last thing I want us to do together before I give you your challenge and we end off the video, which is I'm going to create the game object for the network manager with you. So network manager. And we're going to reset that so it's at the center and add the network manager component, which is all set up pretty well. We don't want to change really much of this. And we also want to add the HUD so we can see it in the UI over here when we run. And now to the challenge. So I'd like you to assign our custom player. So we've just made the player game object, put the asset for the tank model in it, and now we want to actually spawn it in for a player whenever they connect. So you've got to remember to make sure that the player is a networked game object so that it has the network identity component. If you remember that back from section 1, the network manager only allows you to spawn in objects with network identity. Remember to actually assign the player in the network manager, otherwise it's just not going to spawn anything in. And finally, create some spawn points. This is up to you. We used the network start position component in the last section to define some places in our scene where players will spawn in, and then by default it'll just spawn in randomly. But on the network manager you can change it to say round robin, which means go from 1 to 2 to 3 to 4, back to 1 to 2 to 3 to 4, as opposed to picking randomly. So yeah, it's really about step 1 and 2 here, get the player spawning in. As for where they spawn, it's not really too big of a deal. Just set up some places in your scene so that when you spawn them in, the tanks don't overlap each other. So have a go, pause the video, and I'll be back in a second. Okay, I hope you paused the video and gave that a go. Let's go back into Unity. So I said we want to make sure that the player has a network identity component. Okay, let's add the network identity component. So now this is a networked object. I need to make sure to click on overrides and apply all. So it applies it to this prefab. So when I delete it from the scene and look back in my assets, it actually has a network identity. It's all there. So that's step 1. Step 2 was go to our network manager and add the player in as the player prefab, and it's all happy. And then finally, pick some spawn points. So I'm going to just create an empty game object. What I'll do is I'll actually make a cube just so I can kind of see where it is in the scene. So I can put a spawn point. Let's drag the X here. Okay, I'll do this as a spawn point, so at like 0, 5. And I can duplicate that and make another one at -5, like so. So these can be our 2 spawn points for now. So as I said, I was using them as cubes just so I could see where they were. So let's just left click, remove all these components and add a a transform start position. It's a network start position, there we go. And then over here, I'll just do the same. So I'll remove start position. And I can call these spawn point. I'll just call them both spawn point. If we look back at the network manager, you'll see here by default it chooses random. So whenever someone spawns in, it'll just pick one of those 2 at random and spawn them in. I'll go for round robin so that every player alternates. And yeah, that's pretty much everything. We just want to make sure that if we go to File, Build Settings, that the correct scene is in here. Now the sample scene is this scene, so we're good. And now we can actually build and run. I'm gonna have to make a new builds folder for this. So builds, select folder, and we're good to go. So now the build is done, and you can see I'm running in the editor. I also have the build running over here. I didn't change the resolution settings or anything, so it's gone full screen. I'll have to change that in a minute, but for testing purposes, it's completely fine. In the editor, I'll click host. We see our tank spawns over here. We've got our player. And if I go over here and join as a client, I should spawn on the right and see the player on the left. So let's hit client. Yep, here we are. If I go back into the editor, we're both here. It's pretty cool. And then over here, back in the build, I can leave. And if I leave, I can then go back to the editor and see player 2 has left, they're gone. Let's quickly sort out the resolution so that when we build, it's a window and not full screen. So we go File, Build Settings, Player Settings, go to the Resolution and Presentation tab, and then we can click on Full Screen Window and change it to be windowed. And then as for the actual resolution itself, I'll go with a 1280 by 720, hit enter, and it's all good to go now. If we were to close this, we could go and run it and it would work. So yeah, that's everything for this lecture. We now have a project set up. So we have our tanks imported, the materials are all fixed. We've made our player prefab, made sure it's a network game object, and our network manager spawns us in when we connect. Obviously, this isn't anything fancy. It's nothing that we haven't already done, apart from, I guess, the tank importing. But we need to get this foundation set up again so that we can move on to make some more interesting systems. So we can have like our mini map, we can have placing buildings, we can have spawning units from those buildings, attacking, destroying the base. All the fun stuff needs to come next. But now that we've got this out of the way, we're one step closer to having an RTS. Thanks for watching, and I'll see you in the next lecture. Goodbye. Hello everyone, and welcome. In this lecture, we'll be setting up movement just like how we had it in section 1. We'll still have to make a few tweaks to the code, and we'll be setting up our own custom network manager, and we'll end up having roughly what we had last time with units that can move. This time there'll be obviously the tanks, and then we can take this from here so that we can actually have in each 4 corner, we can spawn bases, then we can click on bases and have units spawn. Because right now, it's nice and all being able to move our unit, but we want to be able to spawn 100 units or however many units. So we're going to need to make somewhere to actually produce units from, and then have it so that we can control our army of units. That'll be in the next lecture or two. For now, let's get the movement working. So the last 2 lectures were really just setting up our project, importing stuff and getting it all ready again. So now let's start thinking about the logic of our game. Some of the logic of our game I already kind of did in section 1. The movement is very similar to what an RTS would be. It's definitely a bit more complex in an RTS, but it's roughly the same with a nav mesh, an agent, and raycasting. So we're going to get that set up again in this lecture so that we're ready with moving units, and then we can, in the next lecture, think about selecting our units, producing our units from buildings, and so on. One thing that we'll need to do is write our own network manager. We need some custom logic on top of what they already provide in the network manager that comes out of the box, so we'll have to write our own. So let's head over to scripts and make a new folder. I'm going to have a folder called networking, which will just hold the network manager and the network player and maybe some other networking specific things. And then we can separate everything else out into their own folders for things about movement and units and buildings. They can all have their own folders. So we'll just call this networking. And in here, we'll make a new C# script, and we'll call this one the RTS Network Manager. Now we're inside the RTS Network Manager. All we want to do is make sure that it inherits from the built-in Network Manager. Then we can write our own logic on top of that. So let's change the mono behavior, to be a Network Manager, and that requires us to be using mirror. So to do this quickly, Control period, enter, adds using mirror. And then we also don't want the start and update methods. Let's get rid of those. So we're left with this empty script, or relatively empty. It still is a network manager at the end of the day, but we're not writing any custom logic in here just yet. Then if we were to head back into Unity, we can make sure that our network manager, we don't want this network manager anymore, so we can remove this. But it's telling us the HUD depends on it. So let's remove the HUD, then the network manager. Then we'll add back on our custom network manager. So we've called it the RTS Network Manager. And I'll just move that up to the top. And if we go down here, the only thing we really want to add back on, the only thing we changed was the player prefab. So let's go assets, prefabs. Here's our player. Let's click back on the network manager and drag in the player. Also, we prefer to have the round robin for our spawn method right now. And then we want the HUD back as well. Otherwise, we won't be able to see that. So network manager HUD, everything is set up here now. And then the other thing we want to do in this lecture is set up our player to be able to move again. So the way we'll do that is we'll first of all add something in the scene for the player to move on. So let's add a cube, a 3D object cube. We'll stick it at 0, 0, 0 by hitting reset. And we'll just scale this up to be, let's say, 20 by 20. Okay, so we've got this kind of square or cube for the ground. And we can take our camera and just kind of tweak these values to move it back, move it up. Maybe tilt it down a bit more, and that'll do because we can see everything. So I'll go for 40, and then we'll go for like 15 and 9. It doesn't really matter too much as long as we can pretty much see everything. Now if we head to the scene and look at our spawn points, they're all over the place. So we quite like to put our spawn points, first of all we want to make sure they're on the ground. So right now they're in the ground. If you look here, we'll come across at the side, they're inside the ground. So they need to go up to 0.5 to be on the ground. So let's set that to be 0.5. And we kind of want them to be in the corners. The 4 players will spawn in the 4 corners. So let's bring it over here to get a rough estimate by grabbing this kind of square that's on the floor. And then it's roughly about 8, 8. That would be an okay place to spawn the player. So because that's 8 and 8, we can then go to the next one and go for 8 and let's say -8. And make sure the Y is at 0.5. So now we've got these 2 spawn points on the left. Let's select them both with shift left click, hit Control D, and that'll duplicate them. And then just make sure they're called spawn point again. And now these are both still on the left. We want them both to be on the right. So let's set this to be -8. And now hopefully, if we put them all together, we can see we've got there, 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 and there. So all 4 of them are laid out. Now, I think when they are used in this spawning, they go in the order they are in the scene. So player 1 will be here and player 2 will be there. And usually, you find that if you have 2 players, they spawn on either side. So let's put the one here, and then the other one over here. So drag this up. So we've got point 1, 2, 3, and 4. I'm also going to quickly rename the cube to be floor. And then what we want to do now is make sure that this is a static object. Because if we take this as static, like we did back in section 1, it means that we can then say in the navigation tab, which I have all the way over here, it's kind of hidden. Navigation, if you don't see it, it's window AI navigation. And we can then hit bake. Then go into the bake tab, bake like we did back in section 1. And now this ground is ready for us to be used by navmesh agents. If you remember back to section 1, and I hope you still have it on your PC, if you don't, you can grab this code off the GitHub that we have linked in all the lectures. But what we have is, on the player, let's go to the player, we want to have a movement script, just like we had last time. So what we can do is, we can go to that folder, or the file, where we had the player movement script, and I'm going to simply copy paste it into here, or I can just drag it in. Obviously I've dragged it into the prefab, so I'm going to have to move that around. If I close that, what we can do is I can scroll down to scripts. Let's make a new folder all about units. And then I can go back to the prefabs, grab the script, and drag it into my new folder. So now in my units folder, I have the script from last time. Now let's just have a look to familiarize ourselves with the script. So what does it do? It has reference to a navmesh agent, so we can set it where to go. Reference to the camera, which is where we do the raycasting from to see where we want to move to. And if we go down to the client code down here, we cache the camera when we start. And then every frame we say, well, if we do own this object and we did press the right mouse button, then do a raycast. And if we hit something, then move. Or tell the server where we want to move. Then the server says, okay, on the navmesh, try and find if this position is valid. If it is, then we use it here to set the navmesh agent. And that's exactly what we want for now. We will be expanding upon this, but it doesn't make sense to just recode the exact same thing with you, so we'll just reuse the code we've already written. Now, I want to rename this unit movement now. I like to refer to the things as units. So unit, and let's rename the actual file to be unit movement. Now, if we head back into Unity, now that we're back in Unity, we'll go to the tank, and we'll add on our RTS, sorry, our unit movement script, and that needs reference to a navmesh agent, so of course we'll add the navmesh agent. And I like to put the kind of built-in components higher up. So if we look down at our unit movement, let's add reference to navmesh agent by dragging that in. And now we need to set up the navmesh agent, because if you look in the scene, the navmesh agent doesn't really fit the tank at all. The height is pretty much right, actually, but the width, the radius, sorry, is not correct at all. So you can see all the settings here of how to change the radius and the height and the offset, for example. So now it's time for your challenge. To customize the navmesh agent, there's 2 steps here. Step 1 is kind of more important, which is to tweak the radius and the height so that the tank is inside. Otherwise, when we start adding walls and obstacles, the tank will be able to pass through them or like clip through them. It'll be a bit weird. Just make sure that the tank fits nicely inside. Doesn't have to be perfect as long as the majority of it is in there, and I'll be showing you my settings in a minute. And then as for speed, angular speed and acceleration, which is just all about the movement, this is kind of hard to estimate without being able to test it. So we can of course set those values while testing, or you can wait till after the lecture and have a play around with it yourself. As long as you get the radius and height good, then that'll be fine. So have a go, pause the video, and I'll see you in a minute. Okay, so I hope you paused the video and gave that a go. Let's head back. As I said, we'll be tweaking the kind of the speeds in the actual game when we're testing, but as for the radius and height, we can do that right now. So if we go into isometric mode, so we have perspective mode, which has, you know, perspective and depth, or we can click isometric mode like this. And that allows us to, if we look at the top-down view, get a really nice view. Because if we were in perspective, you see it's a bit distorted because of our perspective. But if we get it like this, we can very easily tweak the radius. And like I said, it's going to be impossible, really, to get it to fit properly. I'd like to go to the point where pretty much all of the tank's tracks are inside. Now, we could go for all of the tank's tracks, like around here. Obviously, this would then mean, if I hit this again, it would now mean that, for example, the tank wouldn't be able to the wall wouldn't be able to be here, the wall would be here. So there's still going to be a gap between objects now, because we've gone bigger than the tank. The tank wouldn't be able to fit through a gap unless the gap was like between here and between here. If the gap was smaller, like between here and here, the tank wouldn't be able to fit through. So like I said, it's really up to you to get it right. I'm actually probably going to go for a little bit smaller than this. I'm going to go for 1.75. I think that'll do. Then for the height, we can click these cone-looking shapes. So if we click on this, we can see that the height goes up to just about here, which is probably fine. At the end of the day, in our game, we don't have anything that we need to go under. So the navmesh system is never checking, like, can we fit under this object? But I still think at the same time, it also makes sense to have it kind of encompass this. So let's just increase it slightly to, let's see, the height is 2. So let's try 2.2 or 2.3. There we go. 2.3 is good. So now the tank is good. The navmesh agent fits the tank pretty well. We don't really care too much about the gun. And then what do we want to do now? Let's go back into perspective. We want to try, obviously, playing the game. But one last thing, if you run the game now, you'll get one error, which is that we still have some code that we copied over that's using, let's head over to scripts. We're using in the unit movement script, we're using the old input system to read the right mouse button click and the mouse position. But we've actually enabled the new input system and we've disabled the old one. So what we need to do is we need to find the equivalent of this line. So the equivalent of get the right mouse button is, we can say if not mouse. So if I type in mouse and then hit control period, it'll give us the option to be using the Unity engine.input system. So let's add that. So if not mouse dot current, and then we want to check the right mouse button, so the right button dot was pressed this frame. So if it was pressed down this frame, then it's the equivalent of what we had, which was input.get mouse button down. We also need to remember to change this line. So instead of input.mouse position, we have to do mouse.current.position. And for some reason, I don't know how or why it works, but it gives us this vector2 control. If we want just the actual vector2 off it, we can say read value. It's a function, it returns a vector2. So this is the equivalent. You know, you might think, well, it's using a little bit more code. The new input system is obviously slightly more advanced than the old one, but it's just much better in terms of like capabilities. Just how it works makes it a lot more sense. And I will be covering it a bit more as we add more input for like the camera controls and stuff. But for now, this is fine. It's just kind of a hot swap of what we already had to work with the new input system. And finally, when we move the position on the server, we also want to sync it on the client. So let's go back and remember the final thing we need to add is the network transform component. And I'll move this up to the top near the identity. And it's not client authoritative, and these settings are fine. So now we can move on the server and see it on the client. Everything is good to go. We've got our spawn points, we've got our nav mesh bait, we've got the network manager spawning in our player, and our player with all this code on it, with the movement input to move the nav mesh agent, which then gets synced. Everything is all there. Let's give it a build. Now that the build is done, I'm going to go host over here and join as a client here. And then if we click start moving, you see I tell the server to move me, it starts moving me, and then the position is synced back to the client. The only reason, see, obviously there's always going to be a delay with networking. The main delay here is actually just the fact the nav mesh agent has such a low acceleration that when we click, it takes ages before it starts moving. We could, over here, start tweaking the settings for the tanks. If I select them both, I could say that the acceleration and the angular speed are really high, and it'll feel a lot more responsive. Obviously, it won't look as good. You want there to be, you know, it's a huge tank, so it won't be able to rotate very quickly. But for now, you know, just so it's responsive, this is all right. And I go back over here and I click to move it around, and it works just fine. So yeah, that's it for this lecture. We now have movement working again. We've got our tanks in, the nav mesh agent, everything is all set up. We've got our custom network manager script, and now we can actually start making some buildings to spawn in more units. Because right now it's pretty boring having an RTS with just one unit each. We want to be able to spawn in many units. So we'll get started on that over the next couple of lectures. I'll see you there. Goodbye. Hello everyone, and welcome. In this lecture, we'll be creating a unit spawner and a way to actually spawn units in, so that we have something like this. If I was to join, we get unit spawners, and if I then click, I spawn in some units. They all, at the moment, spawn in on top of each other and start, you know, fighting for the same position. So it's not ideal, but they spawn and they all listen and move around, and you see it happening over here. Then I can spawn in units over here and do the same thing. And for now, there are no limitations, so I could click forever and, you know, spawn in as many as I'm allowed before mirror crashes, but the point is that it works, and yeah, we should probably shrink the tanks, increase the size of the game, and so on and so forth. But for the sake of the lecture, you know, getting all this working, it's pretty cool, and I hope you're looking forward to it. Let's get started. So right now, if we look at our player prefab, you'll notice the player prefab is one of the units. And in the RTS, as I've mentioned before, we don't want the player to be a unit, we want the player to command units. So therefore, the player object shouldn't be this tank with all the movement on. So what we should do is we should actually rename this to just be, for now, unit, and then later on we can make more units, different types. So we have this unit, and right now, it's still going to spawn in that unit whenever we join. So we want to make a separate thing for the player. So let's just make an empty game object, and we'll rename it to be player. I'll click here to reset it, so it's all centered. And we just want to add on the network identity script. Just that's the minimum requirements for the player game object. We'll be adding to it, but right now we're fine how it is. And we want to make that into a prefab. Let's drag it down here and remove it from the scene. Then we can go to the network manager and swap that out. We'll say spawn in the player, not the unit. But then it seems like we've taken a step back because we did have a working unit that could move, but now we have effectively nothing. The unit never spawns. We need the server to spawn in units. So how we're going to do that? Well, for something to be spawned in by the server, we have to actually add it to this list here of registered spawnable prefabs. So just click plus and drag in the unit. So we're saying this unit is something that can be spawned in over the network. As we get more and more networked game objects that need to be spawned in, then we can make a more automated way to add it to that list. But for now, it's simple enough just to click plus and drag in the one unit. But then how are we actually going to spawn in that unit? We need something that the player can interact with to tell the server, you know, I want to spawn in a unit. So what we'll do is we'll give each player a cube that spawns in where their kind of base area is, so where their spawn point is. We'll have a little cube here. And if the player for that cube, so for example, if I'm player 1, I'm in the bottom left. If I click on my cube, it'll then tell the server, I would like to spawn in a unit. And then for now, the server will just listen and do it. It'll just spawn in the unit. Then in an upcoming lecture, we can change it so that units cost a certain amount of money, take a certain amount of time to produce. Maybe buildings have a cap on how many units they can produce at once. So we can add in all those limitations on the server side at some point. For now, we'll just let the player click as fast as they want and spawn in as many units as they want. To do that, we'll actually need the game object for the little spawner. So let's make an empty game object called the unit spawner. and I'll just reset this for now. And let's make a prefab out of that, so drag that down. And I actually usually prefer to work on prefabs in the actual kind of prefab mode. So if we double click it, it's like it's in its own scene and we can work on it here. So let's give it something we can actually click on. So right click, we'll add a 3D object cube for the body. And right now it would be half in the ground, half above ground. So let's move it up by 0.5 units. So now it's pivot points on the ground and it's all above ground. It's all good. One problem is because our ground is gray and this is gray, they both have the same material. It's really hard to see this. So let's go into the assets, materials, and make a new material called the unit spawner _ matte. We'll keep this as just a temporary thing because eventually we'll assign the colors of these objects to be the team colors, but we don't have team colors just yet. So let's assign that and we can make it whatever color you like, something that stands out like red. Okay, and we go back to the prefab now. We have no code really on the unit spawner, but on the cube we have all this. And we do want the mesh filter and renderer so we can see it, but the box collider should actually not be on the child because all our code is going to be here and we need to find out whenever we click on the cube. So if I have the box collider, if I had it back here, I just need to bump it up by 0.5 units. So let's hit this by 0.5. And now you can see the box matches the cube. And now we can start writing some code on here to say, when I click on this box, wherever it is, so in my corner, when I click on it, to then send a command to the server to say, hey, please spawn me a unit. Let's head to the scripts. And the units, actually, no, this is going to be a building, right? We're going to have different buildings. So I'll make a folder called buildings. And this is going to be the unit spawner. So let's make a C# script for the unit spawner. And we will be, as I said, we'll be developing this further throughout the course so that it can do more fancy things like queuing units and having a cap and, you know, checking price and reducing the player's money. But for now, we'll just listen and spawn in. So let's get rid of start and update for now. And what we want to do is we want to make sure this is a network behavior. Obviously, it's going to be a networked object. So network behavior, just like our scripts in section 1 and our movement script is the same. And let's import mirror. We've done this plenty of times now. I don't have to keep saying exactly how to do it. And what we want to do is we want to have reference to the thing to spawn in. So let's have a serialized field private reference to a game object. So that's going to be the prefab. So we'll call this the unit prefab. And we're going to have some server and some client code. So like I said last time, I like to make regions for the server and regions for the client so that we can easily kind of fold up the server and the client code separately. Let's do the server code first. I usually like to start there because at the end of the day, the server code is all the logic and the client just simply calls it. So we'll make a command to spawn the unit in. So it has to be a command. And remember, commands start with CMD. So CMD spawn unit, like so. And all we want to do for now is just spawn a unit in. Now remember, this code is being run on the server. So the way you spawn in a unit over the network is you first of all spawn it in normally with instantiate on the server, and then you use a method in mirror to actually spawn it on the network and assign the owner. So let's spawn it in on the server. So we'll make a game object and we'll call it unit instance. And that'll be instantiate. So we're going to spawn in, and what are we instantiating? We're instantiating the unit prefab itself. Where are we spawning it in at? Well, let's actually also set that up in the inspector. So serialized field private transform. And we're going to set up on the prefab the location as to where to spawn the unit. So if I just show you what I mean, what we can do is on the prefab, we can create an empty game object, and it's going to not have anything on it. It's just going to be the spawn point. So I'm going to say, well, if this is going to be where we spawn in the unit, then I want the actual unit itself to spawn in maybe over here somewhere. So at like 1.5. So you imagine in the world, the building's there, and this is where the unit will spawn in at. Let's quickly rename it to be the unit spawn point and go back to the code. So we'll just call this unit spawn point. And we will then pass that in here. But we actually need to pass in the position of it, not the thing itself. And then finally, the rotation of the object will just be the same as the spawn point. So the unit spawn point dot rotation. And this has just gone a bit past the end of the page, so I'm going to put this onto multiple lines so we can see it. and we need to hit semicolon. And now that's spawned in, but that's just on the server. There's nothing networked about this right now. We need to actually spawn it on the network. The way you do that is in Mirror, you do network server.spawn. And that has to be passed in a game object. And what it'll do is it'll spawn it, as it says here, spawn the given object on all clients. And it'll cause a new object to be instantiated from the registered prefab. So it has to be a registered prefab. Like I said earlier on, we registered it on the network manager. So let's pass it in the unit instance. And we want to also pass in the owner connection. So if we don't pass this in, then it's not belonging to any of the clients. It's just a server only object. But in our case, we want the owner of this unit, the unit to belong to the player this spawner belongs to. It's the same owner. So what we can actually do is we can just pass in the connection to client. This connection to client exists in the network behavior. So because this spawner belongs to me, the unit that spawns will also belong to me. I'm basically on the server saying, give authority to the connection to client. So remember, this is the server where it's running, and the server will have a connection to this client that owns the object. So we're just saying, give that person the ownership over the new unit. And for now, that's it on the server. We just want to spawn units in. Then on the client, we want to actually call this command whenever we click on this object. So an easy way to know if we've clicked on this game object is to add an interface up here. Now, if you don't know about interfaces, this one in particular, how it works is Unity has their built-in event system it's mainly designed for UI. When you use UI elements, you want to check, for dragging items in inventory or just clicking on stuff on the UI, you use these events. And you can actually use them for objects like this. Even though it's not user interface, you can still use it. So I'm going to say iPointerClick handler. And by adding this, and also I need to do control period and add event systems. By adding this, I can then do control period again, and it'll give me this method onPointerClick. I'm also going to quickly move this down. Let's move it down to the client code. So all this simply means is Unity will call this function for me whenever I click on this game object. It's that simple. It's just saying whatever game object this script is attached to, call this method when you click on it. Now it doesn't check by default, which mouse button you clicked. So we have to do an if statement here saying if the event data that we've been given, if the button does not equal, and then I don't know, which button do we want to do? Well, pointer event data dot input button dot, and it gives us left, middle, or right. So I'm going to say I want left. So if the button is not the left mouse button, then return. So we want the left mouse button to be the one to spawn in units. We also want to say, if we don't own this object, then don't even bother asking the server to spawn it. Because right now, we could click on the enemy person's base, and it would try and tell the server to do it. It still wouldn't work, because you can only call commands if you own that object. So it's protected, it's safe, but we might as well not even bother telling the server to try do it if we don't own their base. So let's say if not has authority, return. But if these two conditions are met, let's just tell the server that you want to spawn a unit. So cmd spawn unit, like so. And that's it for the spawning code for now. So all we simply do is we have this unit spawner, and Unity knows based off this that if we click on it to call this method. So when we click on it, check, well, if you didn't press the left mouse button, return. But if you did, make sure you have authority if you don't return. If you do own the object, then tell the server to spawn it in. And the server will then say, all right, I'll spawn in this prefab on the server, and then I'll also spawn it in on the network so you guys all get the object on your clients. And the person who owns this object, the spawner, will be the owner of that object. And now that we've got this, what we can do is we can head back into Unity. And the only problem is, even though the spawner works, we still have to add the spawner script. So let's do that. Let's add the unit spawner. We want to put this at the top. I usually like having this up here. We also, as it says here, we need the prefab. So we can go assets, prefabs, and here's the unit. So let's click back here and drag in the unit as the unit prefab. And then the spawn point is here. But this spawner itself is never spawned in, right? We still need to spawn this in somewhere. And you could argue, should we make the unit spawner be the player? And we could do that in the short term, but we're going to change it at some point anyway, so it's not a good idea. What we want to do is we want some code in our custom network manager to say, when someone joins, spawn in a spawner for them. So then for the network manager, we should go back to assets, scripts, networking, network manager, and we want to override, like last time, we want to override one of the callbacks for whenever a player is added. Whenever a player is added, give them a base, or give them a unit spawner. So override void on server, because it gets called on the server, add player. Do the base logic. If I hit F12, I can see the base logic is spawn in the player object, which is now just like the empty game object. And wherever that gets spawned in is also where we want to spawn in our base. So one thing we can do is we can say instantiate. Now we need to have something to instantiate, which is the spawner. So let's set it in the inspector. We can say serialized field private game object, the unit spawner prefab, and then we can take that and spawn that in. And where do we spawn it in? We want to spawn it in wherever the player was spawned in. And the way you can get where that is you can say con, so the connection to that player, dot identity, which is the kind of player object, dot transform.position. So that's where that player was spawned in. And then what rotation do we want for this game object? Oh, we can just say con.identity.transform.rotation. And yet again, it's kind of going off the edge of the page, so we can hit enter a few times to be able to see all this. Remember a semicolon. And right now we spawn it in, but we need to obviously spawn it in for everyone over the network. It's the same thing. We're going to do a network spawn. So we need to say game object, and we'll call it the unit spawner instance equals this. And now we've got it on the server only. Just like back in the unit spawner, we also need to network server.spawn like this. So I'm going to copy and paste this, but it's not quite the same. We want to spawn in the unit spawner instance. And who owns it? Well, we don't have this connection to client, but handily enough for us, we're in the function where we actually add the player, and we've got this connection here, which is the connection to the client. So just change this to be con, and we're done. So I'll give you a quick run over the code in case you're a bit hazy on some of it. So this is the flow of things. We connect to the server adds us as a player, it does the normal stuff, and then it will spawn in a base for us at wherever our spawn point is. And then after it's spawned in on the server, it will then spawn it in on all the clients and give ownership to us. So we now own our own base. That's good. Then on the base, it has this script on the spawner, and we own this object, remember. So then Unity says, okay, iPointer click handler. Whenever you click on this game object, if you press a left mouse button and you own this object, then tell the server to spawn in a unit. The server then says, okay, spawn in the unit prefab that you've linked. Spawn it in at the spawn point's position and rotation where you've set that up. And that's spawned in only on the server again. So network server.spawn, which will spawn it in on all the clients, and give ownership to whoever owns this object. The unit spawner, we own the unit spawner because we assigned it back in here. So that's the whole flow of things. One last little fiddly thing is this iPointer click handler. As I said, it's built for UI. You've probably used it for UI before, but you might not have used it for game objects. So it's a little bit weird. To use it for game objects, we have to go back into Unity. And we need to, first of all, add an event system. Now, if you added some UI, like a canvas, it would actually add an event system for you. But we have to add it manually. I mean, it did the same job, me adding it there. So if you didn't do what I just did, click UI event system. Okay, you get an event system here. And it's telling you here, you're using the new input system, blah, 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 blah. So just press this button and it fixes it all for you. Okay, and then the last step is to actually go to our camera, which will do the detection of where we've clicked. And we need to add on one component called the physics raycaster. And that's it, that's all we need to do now. And what that'll do is it will allow us to click on the spawner when it spawns here, and it should produce us some units. If we head back to the network manager, you'll see we did register this spawnable prefab, the unit here, but we need to also hook up the other things. So if we go to our assets, prefabs, and here we see them, we want to say the unit spawner prefab is the unit spawner, and we have to still register it as a network spawnable prefab, so add it here too. The reason we add it here is so that we can reference it in our own code. The reason we add it here is because Mirror needs to spawn it in over the network. And now we should be able to build and run. Now it's built, I will host over here, and I'll join as a client over here. And you notice when each person joins, it actually creates for them a cube, which is the unit spawner. And this one is the client over in the end. So if I was to left click on this base, nothing happens. But if I was to left click on this base, it actually spawns me in a unit. Obviously the unit's huge, so I should probably have put the spawn unit a bit, the spawn position a bit further away, or shrunk the tank, but it's all just testing right now. And if I was to right click now somewhere like over here, this unit listens for that and moves over here. If I click the base again, spawns in another unit I can click, and they're both listening, so they'll both go there, and they'll start probably glitching out on each other a bit, because right now there's nothing to say, you know, stop going to your position. So if I click 10 times or whatever and then click here, here's all these tanks. Now, it works. Obviously, it's not what you want for your game, but it works. And you can see now I can command them all to move over here or all over here. And we see it happening on the server too. And if I now on the server start clicking on my thing and click to move, I get my tanks in here and they start moving and listening to my commands. So this all works. It's pretty cool. As we move on with the course, we obviously need to do things like unit selection, because right now the units are all just listening at all times. And we want to improve the movement code so that when you get to where you want to go to, you're then okay, you don't care anymore. Because with navmesh agents, what happens is, if you get to your position, you keep trying to get there. So if you get pushed away, you'll move back again. Now with this, we don't want that, otherwise we keep getting this weird glitchy movement like we do here. And if we try and get all the units to move to the center, then we're going to get a complete mess. So that's some stuff we can sort out over the next few lectures, but it's pretty much working now, as you see here, controlling units, sending them around, spawning more units in, move those around. It's all working. You know, I mean, you could try and push mirror to see how many units can you spawn in. Obviously, I've made a very small arena, so we can't really test that to its full extent, but, you know, have some fun with that. There was no challenge in this video. I couldn't really think of a good one, so I guess just to end off the video, have some fun and try and spawn in as many units as you can and see how far you can push mirror. That's it for this lecture, and I'll see you in the next one. Goodbye.